Hey, it's Mitchell. Welcome to another video in the RSP education series. What if I told you that there's a way to make motors smarter, smoother, and way more efficient? Today we're breaking down variable frequency drives, or VFDs, and the 4 key motor starters that keep industries running, whether it's a massive factory pump or the elevator that you ride every day. These devices are the heavy lifters behind the scenes. Stick around because by the end of this, you'll know exactly how to pick the right starter for any job. It's not just always a VFD. If you like this content and want more educational videos, please like and subscribe. This video is for educational purposes only. Consult a professional for your application. RSP Supply is not liable for any misuse of this information. Now let's get into it. So what's a VFD? A variable frequency drive is like the brainy, high-tech manager of your motor. Unlike a simple starter that just flips the motor on or off, a VFD is packed with smart electronics that let you precisely control speed, torque, and even braking. Think of it as giving your motor a dimmer switch instead of just an on and off button. So we use VFDs and they exist because not every motor needs to run at full blast all the time. Lots of applications like fans, mixers, elevators, conveyor belts, these need to adjust speed based on demand. Here's why they're pretty awesome. First off, there's energy savings. So instead of running at full speed 24/7, the motor only uses the power it actually needs. That equals a lot less wear and tear. Smooth starts and stops mean fewer mechanical shocks, so your motor lasts longer. You also get better control. So if you need a motor to speed up slowly, or do you need a motor to slow down gently? Or do you need a motor to hold a precise speed? VFDs, they do all of these things. The way that a VFD works is it takes your standard incoming AC power and it does some electronic work, turns it into exactly what the motor needs. Here's a simple breakdown. Incoming AC power is converted by DC conversion. So it takes incoming AC power, converts it to DC power. Then from DC power, it's converted into smart AC, right? It's rebuilding the AC power at whatever the frequency and voltage you want. Then there's frequency. That equals speed. So lower frequency equals a slower motor. Higher frequency equals a faster motor. Voltage is closely associated to torque. Adjusting voltage helps control how much muscle or torque the motor has. So do you still need a contactor with a VFD? Sometimes is the answer. Even though a VFD is super advanced, you might still see contactors used in a couple of different ways. One would be a line side contactor that would act like a main power switch to safely connect the VFD when needed, or a bypass contactor. For an example, if a VFD fails, this is going to let you run the motor directly, the old school style, to keep things moving while you fix the issue. So where are VFDs used? Anywhere precise speed control matters. In HVAC systems to adjust fan speeds based on temperature, pumps and water treatment to control flow without wasteful valves, conveyors for smooth starts, stops, and variable speeds, elevators and escalators for smooth acceleration and braking, robotics and CNC machines for ultra-precise motion control. So a quick recap, reversing starter. This one's all about changing direction, like making a conveyor belt run backward or a mixer spin the opposite way. How? It uses 2 contactors wired in a special way with an interlock to make sure that they never both turn on at once, which would cause a short circuit. Reversing starters are essential for hoists, garage doors, or any motor that needs forward or reverse action, cranes as well. Star delta starter. This is for big motors since they cause such a huge power surge when they're starting up. Imagine flipping on a giant fan. It's a jolt to the system. A star delta starter helps ease them into action. It does this by using 3 contactors and a timer to first start the motor in star mode, lower voltage, gentler start, and then switches to delta mode, full power, once it's moving. This is to help prevent tripped breakers, flickering lights, and stress on motor windings. Soft starter. So if a motor were a car, a soft starter would be like gradually pressing the gas pedal instead of flooring it. So the way this works is it uses solid state electronics like a dimmer, for a light switch example, to ramp up voltage slowly. Some even have a bypass contactor to take over once the motor is running. Soft starters, they're very useful to reduce mechanical shock, noise, and power spikes. Great for pumps, compressors, and big industrial fans. Then, of course, what we discussed mostly, the VFD in this video. That's the ultimate motor controller. Doesn't just start the motor, but it fully manages speed, torque, and braking. It does this by using advanced electronics to reshape power on the fly, giving you total control over your motor performance. This is all done to save energy, reduce wear, and it lets you fine-tune operations for maximum efficiency. So final summary, reversing starter for motors that need forward and reverse, star delta starters for big motors that need a gentler start, soft starters for smooth, shock-free ramp-ups, VFDs for full speed control, energy savings, and smart operation. Each one has its place. Pick the right tool for the job. For a full line of contactors and starters and hundreds of thousands of other industrial automation products, go to our website. That's at rspsupply.com.